confidence interval for a single proportion. So, two scientists want to know if a certain drug is effective against high blood pressure. The first scientist wants to give the drug to 1,000 people with high blood pressure and see how many of them experience lower blood pressure levels. The second scientist wants to give the drug to 500 people with high blood pressure and not give the drug to another 500 people with high blood pressure and see how many in both groups experience lower blood pressure. Which is the better way to test this drug? You should all know this from Unit 1. It's B. What does this have to do with confidence intervals? Well, GSS asked the same question and got this distribution of responses from the 2010 survey. So, 571 out of 670 people, which is 85%. 85% of people understand basic experimental design. Good for them. So, we would like to estimate the proportion of all Americans who have good intuition about basic experimental design. That is, would get the correct answer to this question. So, first of all, what is the parameter of interest and what is the point estimate? Parameter of interest, the proportion of all Americans who have good intuition about experimental design. Right? Our parameter is about the entire population. The point estimate is going to be the proportion of sampled Americans who have good intuition about experimental design, which we just said was 571 out of 670, which is about 85%. So, sample proportions, also nearly normally distributed. We talked about this a little bit in our sampling distributions. Sample proportions will be nearly normally distributed with a mean equal to the population mean p, and a standard error equal to square root of p 1 minus p over n. Right? Mean is p, standard deviation of the sampling distribution, or standard error, is going to be p times 1 minus p over n. Remember this? Does this look familiar? It should look familiar. I really hope it looks familiar. Only true under, come on, these conditions, right? Independence, NP and N1 minus P at least 10, which is at least 10 successes and at least 10 failures. But, right, this is using the population P, the true population proportion, and we don't know what P is. So we're going to use P hat because that is our best estimate of P. So, right, our confidence interval is going to be always in the form point estimate plus or minus the margin of error. The margin of error is composed of the critical value, that's the z-score, times the standard error of the point estimate. And the standard error of the point estimate for a proportion is square root of p hat 1 minus p hat over n. Right, it's that formula that we just saw. And this is going to be that z-score that you get from doing the inverse norm. So, our critical value for a 95% confidence interval is 1.96. If you do this as many times as I have, you will memorize that. Otherwise, we can get this by doing inverse norm, 0.025. Remember, take that 5% and divide by 2, 0, 1. And that is going to give you that. The standard error is going to be square root of p hat 1 minus p hat over n. Our p hat for this one was 85%. So square root of 0.85, 1 minus 0.85 over, what was it, 670, I think was our total number of people. My calculator's not behaving. Oh my god, you gotta be kidding. There we go. And we take square root of that, and that gets us 0.013 as our standard error. .014-ish. All right. So our confidence interval is going to be 1.96 times this standard error, which comes out to be 0.014. Right? So they found out that 85% of Americans, 85% of the 670 sampled Americans, answered the question on experimental design correctly. Estimate using a 95% confidence interval the proportion of all Americans who have good intuition about experimental design. Given is that our n is 670, p hat is 0.85. Check the conditions, independence. A sample is random, 10% condition, 670 is less than 10% of all Americans, so we can assume that the response is independent, right? Independence is going to include our randomness condition and our 10% condition. Then we also check the large counts. We have more than 10 successes and more than 10 failures. If you're using p hat, you don't actually have to do the math here. Look at the actual number of successes and actual number of failures, because 85% of 670 should get you back to the actual number of successes and failures. So if you're using p hat, look at the actual number of successes and failures. Actual number of successes and failures, both at least 10. We're good there. So conditions work. So our confidence interval, right? Our point estimate is 0.85, eliminate D. Our z-score is 1.96, eliminate B. C is missing the big square root. Square root needs to be over the whole standard error. A is going to be your confidence interval. Your point estimate plus or minus the margin of error, which is your z-score times your standard error. And so this is 0.85 plus or minus 1.96 times, what did I say that was, 0.014. So 1.96 times 0.014 is 0.027. So 0.85 plus or minus 0.027, which is going to be 0.823 to 0.877. There we go. There's our confidence interval. You do actually have to do this last step and write it as an interval. This is not good enough. Yeah. 0.82 to 0.88. Good enough. Okay. how many people should you sample in order to cut the margin of error of a 95% confidence interval down to 1%. So our margin of error is equal to 1.96 square root of p hat 1 minus p hat over n. Plug in what we know and solve for n. So we want our margin of error to be 0.01. We still want a 95% confidence interval, so we're using the same z-score. We're going to take the p hat from the previous study and solve for n. So divide both sides by 1.96. We get 0.01 over 1.96. Square both sides. Uh, 0.01 over 1.96 squared equals 0.85 times 0.15 over n. You got to get this n out of the denominator, so you're going to multiply both sides by n, and then you're going to divide by whatever this is, 0.01 squared, or 0.01 over 1.96 squared, and divide that over here. So you're going to get that n is equal to 0.85 times 0.15 over 0.01 over 1.96 squared. Okay. Divided by 0.01 over 1.96 squared. And I get 4,898 people. Technically, you should round up 4,899 people. So this is what I got when I put it into the calculator. You should always round up if you're trying to find a minimum number of people. Because if I round down, even though this is only 0.04 of a person, if I round down to 4,898, my margin of error is going to be a little bit bigger than 1%. So to ensure that it is less than 1%, I need to round up to 4,899 people. So always round up. Okay, so do all of this math. Your n should be at least 4,899. Now, here we use the p hat from our previous study. We used the p hat of 0.85. What if we don't have a previous study? What if we don't know what p hat is? Use 0.5. Why? Because if you don't know better, 50-50 is a good guess. But also, p hat equals 0.5 is the most conservative estimate. It's going to give you the highest possible sample size. This is a graph of p times 1 minus p for p between 0 and 1. And this gives you the biggest number at 0.5. So that's going to give you the highest possible sample size. So that's the most conservative. That's going to ensure that you meet that whatever threshold you're trying to meet. %. Of 1,001 Americans responded to a 2006 Gallup survey stated that they have objections to celebrating Halloween on religious grounds. At 95% confidence level, the margin of error for this survey is plus or minus 3%. A news piece on the study's findings states more than 10% of all Americans have objections on religious grounds to celebrating Halloween. At 95% confidence level, is this news piece's statement justified? So margin of error of plus or minus 3%, that's going to give us a confidence interval of 8% to 14%. So can we state that more than 10% of Americans have objections to Halloween on religious grounds? No. Because our interval contains things other than things that are less than 10%. 8% or 9% are inside the interval and therefore are also reasonable values. So recap, population parameter is P, point estimate is P hat. Conditions, independence, which you need to check the random sample and the 10% condition. And at least 10 successes and failures. Your standard error is the square root of P hat times 1 minus P hat over N. And your confidence interval is going to be, so confidence interval equals your point estimate plus or minus the z-score times the standard error, and that part is called the margin of error. How to get full credit for a confidence interval on the AP test. So what are you required to write in order to get full credit for something that asks you to create a confidence interval? So, 4 steps. State the parameter you want to estimate and the confidence level to be used. So, state your parameter. We're estimating the proportion of all Americans who understand experimental design, or the proportion of all Americans who object to Halloween on religious grounds. Keyword there being all Americans. Also state your confidence level, 95% confidence. Identify the appropriate procedure and check conditions. What we've done so far is called a one sample Z interval for proportion. So one sample Z interval for proportion. Check your conditions. Random sample, 10% condition should also be in there. And NP and N1 minus P are at least 10. Do state the general formula, which for a confidence interval is exactly this, point estimate plus or minus margin of error. Specifically for a proportion, it's P hat plus or minus Z times P square root of P hat 1 minus P hat over N. You're not going to use a table. You're going to use the inverse norm. You are allowed to use tables on the AP test, but you're not gonna. You're going to use the inverse norm. So it's not really worth it. Show all of your work. That's this part. Show all of your work here. And then you should get an answer that is an interval. And then you conclude, right? That's the interpret the confidence interval. We are blank % confident that the true proportion of whatever the parameter is between blank and blank. If there's some value of interest, like the Halloween example talking about 10%, then you say whether the interval is entirely above or below the value of interest, or whether it contains the value of interest. So, no, we cannot conclude that more than 10% of Americans object to Halloween on religious grounds, because 10 is inside the confidence interval. Ta-da!